So far, we have finished two preparation of alcohol in our previous video from alkene by three ways: direct hydration, indirect hydration, and by hydroboration oxidation, in which A and B is important, and number two from alkyl halide by reacting with aqueous QH. Now we will see number three preparation of alcohol by reduction of carbonyl compounds. Now we're going to see number three preparation, reduction by carbonyl compounds. So do remember student, carbonyl compound means those compound which contain C double bond O. All compound containing C double bond O are referred as carbonyl compound. And why this data has been shown here? Because the valency of carbon has to be 4. 1, 2, 3, 4. So compound containing CO is called carbonyl compounds. Let us see the example of carbonyl compounds. CHO means aldehyde, you know that. And aldehyde also there is C double bond O, so it's a carbonyl compound, and carbon valency is 1, 2, 3, 4. C double bond O is called ketone, which is also carbonyl compound because it contains C double bond O and carbon valency has made 4, 1, 2, 3, 4. Carboxylic acid means COOH, C double bond O, OH, and this is dash been put to make the valency of carbon 4, 1, 2, 3, 4. It is also carbonyl compound. COOR means ester. Ester is also carbonyl compound because C double bond O is present in it, and carbon valency has been made 4, 1, 2, 3, 4. So whether you see aldehyde, ketone, carboxylic acid or ester, so all of them contain C double bond O in them. So therefore all of them are referred as carbonyl compounds. So give example of carbonyl compounds. Aldehyde, ketone, carboxylic acid and ester are carbonyl compound because all they contain is C double bond O. And these all compound can be reduced to alcohol. So when you reduce these all compound, okay, they will reduce to alcohol. Now let us see one by one. First we'll see the reduction of aldehyde, then ketone, then carboxylic acid, then ester. So students, you can see here, this is your aldehyde group. I am writing out here. Here there is no bond, means here is a bond and I'll attach it with R. R means alkyl group. This is the general formula of aldehyde. Now how to reduce aldehyde to alcohol? So aldehyde can be reduced to alcohol by adding any of this reducing agent. Nickel plus hydrogen is a reducing agent. In place of nickel, you can use platinum also, palladium also. So hydrogen plus nickel, hydrogen plus platinum, hydrogen plus palladium is an example of reducing agent. Or you can use sodium plus ethyl alcohol. C2H5OH means ethyl alcohol. Sodium plus ethyl alcohol is also used as reducing agent. Or you can use lithium aluminum hydride. So this is your aldehyde students. Reducing agent can be used as this combination, this or this. Any of these three is acting as reducing agent. And reducing agent is represented by the symbol bracket H. Bracket H means nascent hydrogen. And these all reducing agent, which anyone you can use, will produce two nascent hydrogen. After two nascent hydrogen students, now see what will happen. This R is R, this CH is CH. R is R, CH is here. Let us consider this O is here. R, CHO, R, CHO. After two hydrogen, one will go here and form CH2. The other hydrogen will go here and forms OH. So it will be like this: R, CH, one H, CH2, then O with one other H to form alcohol. So this is how we convert aldehyde to alcohol by reduction. And this alcohol which obtained is second primary alcohol because OH is linked with CH2. This is the reduction of aldehyde. Now see one particular example. I am replacing R with CH3. So you replace R with CH3, then this aldehyde CHO is here. This aldehyde is known by the name acetaldehyde, and use any of this reducing agent which produce two nascent hydrogen out of 2H. First here, CH3 is here. This CHO is here. Now out of two hydrogen, one you take here, so it will become CH2. The other hydrogen you take it to the O, it becomes OH. So we get CH3, CH plus H, CH2, then O, one remaining H will give you alcohol. So this is how we do the reduction of aldehyde. Now we'll see the reduction of ketone. You can see here. Okay, this is C double O, RR is the example of ketone. I am using the same reducing agent. Any of these three can be used here, which will produce two nascent hydrogen. So here what will happen? R is R, C is C, O is O, and this R is R. But double bond O became single bond O. You can write up, down, no issue. It's same thing. Now I have made double bond into single bond. Now there are two H here, right? We are doing reduction, so put one H here and put one H here. So this became your alcohol, and you can see here OH is linked with CH. OH is linked with CH, so it is an example of secondary alcohol, that is 2 degree. Let us go with a particular example for the reduction of ketone. I replace this R with CH3, this R also with CH3, then the name of this compound becomes acetone. The formula of acetone is front back CH3. In the middle, CO is the formula of acetone. Again, I am using the same reducing agent. Any of these three can be used. And this will produce how many nascent hydrogen? Like before, 2 nascent hydrogen. So now see here, CH3 is here, CO is here. You can write out down same thing. Then this CH3 is here. I just put double bond to single bond. Now there are 2 H. Out of 2 H, one H you put out here, 1 H you put out here out of 2 H. And what you get is CH, CH3, OH is called isopropyl alcohol. And since OH is linked with CH, therefore it is secondary alcohol. So on reduction of aldehyde, always remember, on reduction of aldehyde gives primary alcohol. On reduction of ketone gives you secondary alcohol. So do not forget this. On reduction of aldehyde, you get primary alcohol. On reduction of ketone, you get secondary alcohol. So we finished 2 so far. Reduction of aldehyde and ketone. Now we'll see the reduction of carboxylic acid. First ester, we'll see for ester, then we'll see for carboxylic acid. Now you can see a COOR is called ester. This is another R. It can be methyl ethyl. This can also methyl ethyl. So this COR is called ester. If I use the same reducing agent, hydrogen plus nickel, sodium plus ethyl alcohol, or lithium aluminum hydride, this time it will produce 4 nascent hydrogen instead of 2. So out of 4 nascent hydrogen, now how to break this? Okay, so we'll do like this. First you take this RO. To this, from here you take 1 H and becomes ROH, which is here. Now how many H is left here? 3. Out of 3 H, take 2 to the carbon and 1 to the O. You get this RCH2O, then the other H. You can repeat the video again. RO will take 1 of the H to form ROH. Now how many H is left? 3. Out of 3 H, 2 will go to the carbon and form CH2. The other leftover H will go to the O to form OH, and we get RCH2OH. So both are the alcohols, but the OH is alcohol, OH. So you get 2 alcohol when you reduce ester. When you reduce ester, you get 2 alcohol, students. Now, let us see, okay, how to get with a particular reaction. Now, CH3COOH, if here is H, instead of CH3, if here is H, CH3COH, it is called acetic acid. But I replace that H with CH3, so this is called methyl acetate. Okay, this is called methyl acetate, and I am doing the same reduction with 4 nascent hydrogen. So here, out of 4 hydrogen, CH3O, like before, will take 1 of the H to form CH3OH, that is methyl alcohol. Then 3H, which is left here, out of 3, 2 will go here and form CH3CH2. And 1 which is left will go to the O to form OH. So on reduction of methyl acetate, which is an ester, gives you 2 alcohol. One is ethyl alcohol, one is methyl alcohol, and both are the primary alcohols. So far, students, we are doing the reduction of carbonyl compound, preparation number 3. And here you have seen that I have reduced aldehyde to primary alcohol, ketone to secondary alcohol, and ester on reduction gives 2 alcohol, ethyl and methyl, you can see from here. Now we will see the reduction of carboxylic acid, which is also a carbonyl compound. Okay, now the reduction of carbonyl compound. So again, you can put here sodium plus ethyl alcohol, or hydrogen plus your sodium plus ethyl alcohol, hydrogen plus nickel, or you can use lithium aluminum hydride, which is a reducing agent, produces 1 acid hydrogen. And this COH means acid, carboxylic acid, and R can be methyl ether. Now when you do so, what you have to do here is RCOH. I wrote here RCOH. What is not been written here is O. This O, one of the O, will go with 2H to form water, H2O. So I have taken 2H from here, I'll take with O to form water. So what is left here? RCOH is left. And how many H is still left here? 2 more. That 2H will go out here to form alcohol, because OH linked with CH2 is alcohol, and it is usually primary alcohol because OH is linked with CH2. This is how we reduce. Now I am replacing this R with CH3. So when you replace this R with CH3, it becomes your acetic acid. Now again I am doing the reduction with lithium aluminum hydride, which will respond as an hydrogen. Again you write R CH3COH here, CH3COH here. So that means 2H from here will take this O to form water. Now how many H is still left here? 2H will go in place of this O, somewhere here 2H, to form alcohol. And this alcohol is called ethyl alcohol. So I reduce acetic acid to ethyl alcohol by lithium aluminum hydride. This is the reduction process, and you know that OH is linked with CH2, so it is primary alcohol. So students, so far I have explained you is about the reduction of carbonyl compound like aldehyde, ketone, ester and carboxylic acid to alcohol. By you can add any of the reducing agent, lithium aluminum hydride or sodium plus ethyl alcohol or hydrogen plus nickel. All of them reduce carbonyl compound like aldehyde, ketone, ester and acid carboxylic acid to alcohol. So if you want, you can repeat the video. Now we go with the fourth preparation of alcohol, which is utmost important. It's very important reaction, students. Very important reaction from amine. Amine means NH2. In general, we write RNH2, which is a general formula of amine. Now my job is to convert amine to alcohol. So when you convert amine to alcohol, we use reagent like nitrous acid. So nitrous acid is the reagent. You know nitric acid is HNO3. In that nitric acid HNO3, you remove one H and put O, reduce one O from nitric acid, you get HNO2, that is nitrous acid. So when amine reacts with nitrous acid, we get alcohol. But how? How amine reacts with nitrous acid to give you alcohol, that we are going to see now. So do remember, nitrous acid can be written as ONO. We can write nitrous acid can be written as ONO. See here, ONO means what? HNO2. HNO2. This is how you break nitrous acid. Now this nitrous acid can be broken this way, and this is the nitrous acid which is going to react with amine in this pattern. RNH2 is here, RNH2 is here, reacting with ONO, which is nitrous acid. So when these two react, you can make a column of this kind. So from here we can say that we get alcohol as one of the product. The other product will be nitrogen, N2, and the last product will be water, which is here. So whenever amine reacts with nitrous acid, we get alcohol, and it is utmost important reaction, students. Now let us see the particular example of it. I'll replace R with CH3, it becomes methylamine. If I replace R with CH2, it becomes ethylamine. So if I replace this R with methyl, it becomes methylamine. If I replace this R with CH2, it becomes ethylamine, and both I am reacting with nitrous acid to convert amine to alcohol. And nitrous acid can be written as ONO, nitrous acid can be written as ONO. So here R part, that is this, will take OH to form alcohol. This N and N combines to form N2. This H2 and O combines to form water. Similarly down also, CH3, CH2, that is this is ethyl. R part will take OH to form ethyl alcohol, and both of them are primary alcohol. N and N combines to form N2, H2 and O will combine to form water. So students, this is very important reaction in which we convert amine to alcohol. Very important reaction whereby we convert amine to alcohol, students. Amine to alcohol by adding nitrous acid. So this is the fourth preparation of alcohol. So students, we have finished two preparation in this video: reduction of carbonyl compounds and by reaction with amine to alcohol. So now we go with the fifth preparation in our next video, and that is through Grignard reagent. So how we are going to prepare again alcohol from Grignard reagent, we are going to see in our next video. So right now you can take the screenshot to make the notes, and this is very important reaction, preparation number 4, amine to alcohol. Okay, and earlier we did reduction of carbonyl compounds like aldehyde, ketone, ester and carboxylic acid to alcohol. So fifth preparation we do in our next video. Thank you very much.